How did a civilization from 2,000 years ago build structures that still stand today, while our modern bridges and highways crumble within decades? We often think of the Roman Empire as a military powerhouse, but behind every conquest, every city, and every legion stood an army of engineers, master builders who created infrastructure so advanced it outlived the empire itself. So here is the biting question: how did Roman engineers design roads, aqueducts, and concrete that have lasted longer than the empire that built them? Let us dive into the genius of Roman engineering and discover how their innovations shaped not just antiquity, but the modern world. Chapter 1. A biting question: what made Roman roads so durable? Imagine walking on a road built 2,000 years ago, and not just walking, but driving on it. Roman roads were not only the arteries of an empire spanning 3 continents, but also marvels of engineering precision. From Britannia to Syria, they connected cities, armies, and trade routes with astonishing efficiency. So here is the first biting question: what made Roman roads so durable that some are still used today? Roman roads were built using a layered system: layers of stone, gravel, sand, and finally paving stones carefully arranged to allow for drainage and even weight distribution. They were slightly elevated in the center to let rainwater run off, and they were often lined with curbstones and sidewalks. Some roads were more than 1 meter thick, making them incredibly resistant to wear and weather. Unlike many medieval or early modern roads that turned to mud after heavy rains, Roman roads stayed solid, thanks to this smart construction. And because they were built to move legions quickly across vast territories, they were maintained regularly by imperial engineers. Today, parts of the Via Appia and other Roman roads are still in use, proving that when you build something right, it can last millennia. Chapter 2. A biting question: how did Roman aqueducts bring water to millions? Imagine living in a city where fresh water flowed freely to your home, not from wells or rivers, but through a network of pipes and channels stretching dozens of kilometers. That was everyday life in many Roman cities. With aqueducts carrying up to 1 million cubic meters of water per day, Rome had more clean water per person than many modern cities until the 1900s. So here is the next biting question: how did Roman aqueducts bring water to millions without electricity or modern pumps? Roman aqueducts relied on one simple but powerful principle: gravity. Engineers calculated slopes with incredible precision, sometimes descending less than 1 meter over 10 kilometers. This allowed water to flow steadily without flooding or stopping. Aqueducts could be underground tunnels, raised arcades, or even pressurized siphons crossing valleys. They were built using waterproof Roman concrete and lead or ceramic pipes to distribute water to fountains, baths, homes, and even sewers like the Cloaca Maxima. These systems weren't just practical. They changed urban life forever. Public baths became centers of social life, sanitation improved dramatically, and cities grew larger and cleaner than ever before. And remarkably, many of these aqueducts are still functional, like the Pont du Gard in France and parts of the Aqua Claudia in Rome. Chapter 3. A biting question: why is Roman concrete still standing after 2 millennia? Take a look at a modern bridge or building, and then imagine it standing intact 2,000 years from now. Seems unlikely, doesn't it? But that is exactly what Roman concrete has done. Structures like the Pantheon, the Colosseum, and countless harbor walls remain standing, not just as ruins, but as testaments to a material stronger than modern Portland cement. So here is the third biting question: why is Roman concrete still standing after 2 millennia? Roman concrete was made differently from ours, and its secret lies in chemistry and volcanic ash. Instead of using ordinary lime and sand like modern concrete, Roman builders mixed lime, volcanic ash called pozzolana, and seawater. This combination created a reaction that formed crystals of a rare mineral called sturtlingite, which strengthened the structure over time. Even more amazing, exposure to seawater actually made Roman harbor concrete stronger instead of weaker. In contrast, modern concrete breaks down under saltwater corrosion in just 50 years. This discovery has inspired modern scientists to recreate Roman concrete, potentially revolutionizing coastal construction and reducing carbon emissions from cement production. In short, the Romans didn't just mix materials. They harnessed nature itself to create something eternal. Chapter 4. A biting question: how advanced were Roman tools and construction techniques? We often think of ancient builders as primitive compared to modern engineers, but Roman tools and techniques were surprisingly sophisticated. From massive cranes powered by humans on treadmills, to precise surveying instruments like the gramma and dioptra, Roman engineers worked with extreme accuracy. So here's the fourth biting question: how advanced were Roman tools and construction techniques compared to modern ones? Roman engineers had a wide array of tools: pulleys, winches, levers, saws, drills, and even early forms of hydraulic mining equipment. For large-scale projects, they used wooden cranes operated by teams of slaves or soldiers walking inside rotating wheels. These machines could lift blocks weighing several tons, enough to build temples, amphitheaters, and even multi-story apartment buildings. Surveyors used bronze or iron grammas to align roads and aqueducts with near-perfect straightness. Some sites show alignment errors of less than 0.5 degrees over hundreds of meters. They also used scaffolding, hoists, and standardized brick molds, showing a level of industrialization rarely seen in antiquity. In essence, Roman engineers were not just builders, they were innovators, inventors, and pioneers of applied science. Chapter 5. A biting question: what legacy did Roman engineers leave behind? Rome may have fallen, but its engineers left behind a legacy that continues to shape the world we live in. From the very word engineer, derived from the Latin ingeniator meaning creator of ingenious things, to the principles of urban planning, water management, and structural design, Roman influence is everywhere. So here's the final biting question: what legacy did Roman engineers leave behind, and how does it affect us today? The legacy of Roman engineers is all around us, in the layout of modern cities, in public sanitation systems, in the way we construct bridges and tunnels, and even in the way we manage water. Modern architects still study Roman vaults, domes, and arches, techniques perfected in structures like the Pantheon. Urban planners follow Roman street grids and zoning ideas. Civil engineers continue to analyze Roman concrete for sustainable alternatives. Even space agencies like NASA have looked to Roman aqueducts for inspiration in designing water systems for future Mars colonies. In short, Roman engineers didn't just build roads and aqueducts, they built the foundation of modern civilization. So, how did Roman engineers design roads, aqueducts, and concrete that have lasted longer than the empire that built them? Because they understood not just how to build, but how to build to last. Their roads were layered masterpieces of durability. Their aqueducts brought water to millions using nothing but gravity. Their concrete resisted the sea and time itself. Their tools and techniques showed remarkable ingenuity, and their legacy lives on in every modern city, bridge, and innovation. Roman engineers weren't just builders, they were visionaries. And though the empire fell, their work stands tall, reminding us that true greatness isn't in power or conquest, but in creation.